Oh, wow. Okay. Yeah. Okay. So, let's move on to x squared. This is a quadratic function. So the function is a quadratic. The graph is a what? Parabola. Okay? All right. So here we have f of x equals x squared. For this one only, I'm going to use a table of values to graph. Okay? So what we're going to do is x, f of x equals x squared. And here we have f of x, right? So we're going to choose -2, -1, 0, 1, 2. Whenever I'm graphing any function and I'm picking points, it's always important to make a wise decision when you're picking points. You never want to pick like biased points. You want to pick 0 always. And then you always want to pick a couple of positives. You want to pick a couple of negatives. That's where you get the best idea of what your graph looks like. Okay, so when I have -2 for x and I square it, I get a 4. And when it's -1, what do I get? And 0, 1, 2. Okay, so now let's graph this. So at -2, it's a 4. At -1, it's a 1. 0, 1, 1, 2, 4. Okay. Just for fun, if I wanted to do -3 and 3, what do I get? 9 for both, right? So 9. 1, 2, 3, 9. Okay? So now, let's graph this. When you're graphing a parabola, it looks very different from an absolute value because the bottom here is a curve. It's not like a corner like the absolute value is, right? Okay, what do we call this point here? The vertex. Does the absolute value have a vertex? Yes. Yes, that also has a vertex, right? Okay, so that's the vertex. Okay, so now take a look at this. We are graphing an x squared. Like I said, this is the only time that you're going to pick points to graph it. From now on, you graph it using your Algebra 2 knowledge, and that is this. First of all, the parabola, do you see that it's completely symmetric? Right? Left-right symmetry? Okay. So now, if I go over horizontally 1 unit, how much do I go up? 1. I'm going to zoom in here a little bit so I have some space. I go over 1 and I go up 1. So now, if I go over 2, how much do I go up? 1, 2, 3, 4. How are those two numbers related? One is the square of the other, right? So if I go over 1, I go up 1 squared, 1. If I go over 2, I go up 2 squared, 4. If I go over 3, I go up 3 squared, 9. Okay? I put these 3 points, I mirror them on the opposite side, and now I could graph a parabola on the spot anytime. Okay? Isn't that cool? Right? That's pretty cool. All right, so let's do another one. Now, take a look at this. I have x squared minus 5. What does the -5 do to it? Brings it down. So, whereas the vertex here was at 0, 0, what's the vertex of this new one going to be? 0, comma, -5. So I go to 0, comma, -5 and I put in my vertex. And so now I'm graphing a parabola. Whoops. I'm graphing a parabola. That means when I go over 1, I go up 1 squared, which is 1. When I go over 2, how much do I go up? 4. 1, 2, 3, 4. When I go up over 3, how much do I go up? 9. Okay? I mirror these on the left-hand side. 1, 2, and 3. Yes? And then I graph. Okay, so in order to make it nice and round, a little trick is do this part first, make that round, and then extend them.
I'm still confused how you get those points.
First, I put in the vertex. Okay? Then, however much I go over, so if I go over horizontally 1 unit, I go up 1 squared. Okay? If I go over 2 units, I go up 2 squared. Okay, so once I put the vertex, I move to the right 1 space. Yes?
Yeah.
And when I move to the right 1 space, that takes me up 1 space. Okay? Yes. Yes, as long as the A is 1, it's going to be the same for everyone. So let's do this next one. X squared plus 4. Oh, whoops, I kind of jumped the gun on that one. Yes. Okay, so this, yeah. So this moves it up 4 units. So my new vertex is 0 and 4, right? So I put my vertex at 0 and 4, and now I do the same exact thing. I go over 1, up 1, over 2, up 4, and I don't have enough room to go up 9, so this is good enough. Mirror them on this side, mirror them on this side, and then I need to get it to look like a parabola.
Why is it 4?
Because if I go horizontally 2 spaces, I need to go up 2 squared, which is 4. Because it's a parabola, it's a quadratic, squared. So yes, the point is that all of the parabolas are going to look the same. That's the point. Because all the -5 and the +4 are doing is taking the identical parabola and shifting it right, left, up, down. So of course they're all going to look the same. In this case, we have x minus 4. So what is the -4 going to do to the graph? Bring it to the right 4 units. So the new vertex is where? 4, 0. Okay? And then from there, same exact thing. Over 1, up 1 squared. Yes. Correct. Over 2, up 4. And, you know, we could even do over 3. I go horizontally 3 spaces. I go up 9 spaces. Okay, and now where am I going to mirror these? It's symmetric around the line through its axis. So look, if I drew an imaginary line through the vertex, okay, then look at how I mirror them. I went to the right and to the left, to the right 2, to the left 2, to the right 3, to the left 3. Okay, so now my symmetry is gonna look like this. Boom. Okay. Yes? Okay. So you guys go ahead and do the next one. Figure out what the vertex is. Put in the vertex. And then go ahead and graph your parabola, and then we'll compare. That's how this one looks. So it's just shifted to the right 6 units. I'm sorry, it's shifted to the left 6 units. The one next on the list is E, 2x squared. Okay. So what does this do? Narrows it, correct, same exact way as before, but why? Let's see why. Okay, so for this one, is there a shift horizontally or vertically?
No.
There is no shift, so the vertex is still 0, 0. Okay, but now, okay, if I put in x equals 1, right? So let's just do a quick little chart, just so if we, just to see if we could see a pattern. If I put in a 1, right, what's the y value? What happens? 2 times 1 squared. So look, you square and then multiply by 2, right? If I put in x equals 2, it's 2 times 2 squared. So I'm going to square it, get 4, then multiply by 2 and get 16.
So it's like
Do you see it? So narrow. 8, sorry. Do you see? But so do you see the pattern though? What we were doing before is I go horizontally 1 unit and then I go up the square of it. Now I go up the square times 2. So let's do it here. It's different now. So look, if I go over 1, I go up 2 units. If I go over 2, I go up 2 squared times 2, 8 units. And I don't have room for more, so I'm just going to stop there. Let me put in my symmetric points. Times 2, right? Because you have a 2 in front. And now this is going to look like this. All right? It is a parabola, it's just narrower. Before, right, when we were graphing, we were going over 1, up 1, over 2, up 4, so it looked like this. Okay, so now it got narrower. Okay, this next one also has vertex 0, 0, but now, when I put in my 0, my vertex, if I go over 1, how much am I going to go up, do you think? A fourth. A quarter, right? Because it's going to be 1 squared times a quarter. So there. Uh-huh. Not up 4. I would have gone up 1, right? But there's a quarter in front, so it's a quarter of 1. So I just go up 1/4, 1/4. Now, the next one. So I would have gone up 1, right? But now I need to go up 1/4 of 1, which is 1/4. Now let's do the next one. If I go over 2, I should have gone up 4, right? 2 squared. I should, but there is a 1/4 in front, so I go up, how much? 1. Okay? And 1 here. Okay, so let's do another one. If I go over 3, how much should I have gone up? 9. But there is a 1/4, so I go 9 over 4. How much is 9 over 4? 2 1/4, right? So I go up 2 1/4. Okay, so it looks wider like this. Okay? So always think, how much should I have gone up? Multiply it by the number in front. Okay, negative x squared. What's the vertex? 0, 0. Is there a horizontal shift? Nope. Vertical shift? Nope. The only thing is there is a negative. What does the negative do? Okay. It flips it. Now it faces down. What's the mathematical term for flip it around the x-axis? Huh? It's a reflection around the x-axis. Nice. So, my vertex is 0, 0. Now, if I go horizontally one space, I don't go up anymore. I go down one space. And I'll put the mirror point over there. If horizontally I go 2 spaces, where do I go vertically? 4 down. 1, 2, 3, 4. And I mirror. If I go over 3 spaces, how much do I go? 9 down. Right? And then again we curve. And that's how it looks. All right. Okay. Now this one has everything a parabola could ask for, right? What does the negative 5 do? Moves it down 5, and the 3? Left or right? Left. So where is the new vertex? Negative 3 and negative 5. Negative 3 and negative 5. So now, what's this parabola going to look like? Does it face up or down? Down. Is it wider or narrower than a regular parabola? Wider. Correct. So now, what? Because there is a negative in front, it faces down. Correct. It's the A. It's either positive A or negative A. Okay? Okay, so now, here it is. If I go horizontally one space, how much am I going to go down? Half. It would have been 1, but now it's a half times 1. Okay? So half. And I do the mirroring right on the spot. Okay, if I go over 2, how much am I going to go down? 1. I was going to go 2. I would go 2. Sorry. Let's do this again. If I went over 2, I would have gone down 4, but now I'm only going to go down 2. If I go over 3, how much do I go down? I would have gone down 9. I go down half of 9, so 4.5. So 3, 1, 2, 3, 4.5. And my parabola will look like this. Okay? Isn't that cool? You guys are expert parabola drawers now. Okay. Have you seen this chart before? Where? For the absolute values. Okay? Is anything here going to be different? No. And that's the whole point. That this whole thing is going to be the same as absolute value. And it'll be the same as any other function afterwards. Okay? Okay, so now, how do we know if we've really understood something? If you've really understood something, then you can go forwards and backwards, right? Right. So, how do we know if we can really graph an absolute value function If we really know how the graph works, well, if you could write the equation for it based on a graph. Okay? All right. So here, I have 4 of these here. We want to write the equation for the function. So first you have to decide what type of function is it. So first one, it's an absolute value function, right? Okay. What information do I need? What do I need? I need the vertex. Where is the vertex? 5 and -3. What else do I need? A slope. Good. What's the slope? We need to find that out. I go up 2 over 1, so m is 2. Do I need anything else? So if m is 2, does that mean what? That means a is positive 2, right? It's positive 2. Okay, so here it is. When you write an equation, this is the most important thing that I want my students to come out of this class knowing. An equation must have 2 variables. Okay? Equation means 2 variables. X and Y. Or X and f of x. So if you just say 5x minus 2, that's not an equation. I can't do anything with that. That's an expression. It needs to be y equals something. So here, it's going to be y equals, there will be -1 if there, -1 points if you don't have the y equals.
If you were to f of x instead of y equals,
It would be even better. Okay? Yeah. I'm gonna write that underneath right now. Y equals, so the slope is 2, and then x minus the y value, the x value minus 3. No, it's always x minus the number. X minus the number. Because now look, if it's x minus 5, if I set it equal to 0, I get, yes, okay? So that's full credit, or f of x is 2x minus 5 minus 3. That's full credit as well. You get the same credit for both, okay? This one, f of x, is going to move us into pre-calculus and calculus and all the higher level math. Okay, so it's good notation to be aware of. Okay, next we have a what function? Parabola. Right, that means there needs to be an x squared. Okay, all right, again I need the vertex. Where's the vertex? -3 and 4. Okay. How do I figure out the a now? That's the hard part. I need to figure out, if I go over 1, how much am I going vertically? And if I go over 1 or 2, how much am I going vertically? So look, if I go over 1, I go down a half, it seems, right? If I go over 2, how much do I go over? 2. How much should I have gone down if I went over 2? So it's half, okay? So a is 1/2. So now, is it positive or negative? Negative 1/2. So this is negative 1/2 x minus -3 plus 4. But we can't leave it like that, right? Not can you. You must.
isn't it x squared?
Oh yeah, there is a square here. So listen. I don't want minus minus. That's a plus. Okay? Yes.
Why does this go on the outside of
Because that's how the shift looks, remember? Like if you look here, right? It's always, if there is a horizontal shift, then you first add it to the x, then you square it. Okay, so go ahead and do C and D on your own for a minute, please. Let me stop this. Yes, vertex is -7 and 6. So now look, when I go over 2, 2 is usually an easier one to write because 1, right? Since you squared and you get 1, there isn't much information there. How much should I have gone up? 4. How much did I go up? 6. So the 4 became a 6, right? So here's what I do. It was supposed to be a 4. What did I multiply it with to make it a 6? Do you see the reasoning? What am I multiplying it with to make it a 6? So x divide by 4, divide by 4. We want fractions. We love fractions. 3 over 2. 7 -6. So it is -3 over 2, right? So do you see how, right? I'm sorry. Hang on. Sorry. Let's focus on the x for a minute. Do you see how I'm doing this? This should have gone up 4. I multiplied it by something to make it a 6. Is that right? It was supposed to be a 4. What did I multiply it by to make it a 6? 4 times x equals 6, and then you do the algebra there. Okay, so now f of x is 3 over 2 x minus 7 squared, and then minus 6. Okay. All right, here, what is the slope? We go down 1 over -1/3. And what is the vertex? -4 and -4. Oh no, -3, sorry. Okay. Questions? Okay.